Okay, so question 11, complete table of values. In effect, on a non-calculator paper, I would show quite a bit of working for this. So I want to say when x is 5, when x is 2, y would be equal to 2 squared. So 2 squared minus 3 times 2 plus 1, which is going to give me 4 minus 6. Keep pressing my 4 minus 6 plus 1, which is going to give me a total of minus 1, which is what we would hope. We've got a pair of values now. We would hope that 3 would give us 1, so we've got that U shape. But let's have a look. When x is equal to 3, y would be equal to 3 squared minus 3 times 3 plus 1. So that's going to be 9 minus 9, so that would be 1. So that's what we would hope. Right, I'm now going to do when x is 4. When x is 4, y would be equal to 4 squared minus 3 times 4 plus 1, which is going to give me 16 minus 12 plus 1, which will give me which would give me 4 plus 1, which would give me 5. And then finally, when x is equal to minus 1, I'm hoping I'm going to get 5 to match the pattern, but we will see. So when x is equal to minus 1, y would be equal to minus 1 squared minus 3 times minus 1 plus 1, which would give me 1 minus 3 plus 1, which would give me not minus 1. Minus 3 times minus 1 would be plus 3. So that would give me 5. There we go. Okay, so on the grid, draw the graph for values minus 1 to 4. So when it was minus 1, we had the value of 5. When it was 0, we had the value 1. When it was 1, we had the value minus 1. When it was 2, it was minus 1 again. Then we had 3 at 1, and then 4, 5. So I've plotted the points. My next job is to join them up with as smooth a curve as possible. So I'm doing this, I'm spinning my laptop. It's always easy to draw a curve with your wrist on the inside of the curve. So I've actually turned my laptop screen upside down. My wrist is actually over here. So joining them up with as smooth a curve as I can. I'm not great at this on a laptop. I'm looking at, I'm just getting in the way. Yeah, it's pretty smooth. So that's my graph. And then final part, using your graph, find estimates for the solution of x squared minus 3x plus 1 is equal to 0. So compare that with the original equation. All we've got is it's the same equation. So all we're doing is looking when y is equal to 0. So y is equal to 0 is that line there. So I just need to read off these values. So that's my first one, and then that's my second one. So I'm looking at 0.4 and 2.6. Those are my two values. Okay, and that's it for this question. So if we look at the mark scheme, then what does it say? For the table of values, it's 2 marks for a correct table. So if you've got 2 or 3 values, you can still get 1 mark, but that's it. For this one, it is for at least 4 correct points plotted, and then this mark is given for fully correct curve drawn. So 2 marks available there. And then final part, this mark is given for showing the marks indicating the intersection. So I actually pick up the first of these 2 marks for showing where they cross, which was kind of the little crosses I did there, and then mark for the 2 answers. It does say, though, you can award anything in the range 0.2 to 0.6 for that value, and then anything in the range of 2.4 up to 2.8 for that one. So I'm slap bang in the middle for both, which is great. Okay, question 12 then. Express 0.1 and then 17 reoccurring. You must show all your workings. So I tend to say x is going to be equal to the original number. I will then multiply by a number to make that reoccurring pattern overlap itself. So I'm going to have to multiply it by 100. So 100x is going to be equal to 11.717, and I have that reoccurring pattern. I'm then going to take one of them away from the other. So I'm going to take 100x minus x would give me 99x, and that's going to be equal to 11.6. So if 99x is equal to 11.6, then x is going to be equal to 11.6 over 99. And then I'm going to start to look at how I can simplify that fraction. Most straightforward way, I'm going to times both parts by 10. So 116 over 990. Right, then I'm looking for numbers that go into them both, and I'm struggling straight away to spot numbers that would go into them both. I mean, we could go by 2. Trying to spot anything else. Would 4s go into them both? Don't think so. So I think I can only cancel down by 2. 58 over 495. Can I go any further? 3 wouldn't work in either. 4, 5. No, I think that's going to be it. So 59 out of 58, sorry, out of 495. Although I probably, because it doesn't say in its simplest form, I could probably have got away with that as my answer. Right, let's have a, is that it? That is it for the page. So let's have a look. M1, this mark is given for setting up the initial equations. So we can go, there. So it should really be there. Mark for cancelling, and then mark for simplifying. And we could have got away with, we could have answered 116 out of 990, and the equivalence. So 116 over 990 would have been fine. I do get marked for the simplified version though. Right. Question 13, write as an ordinary number. So in effect, the -3 means that I'm adding 3 zeros. Is an easy way of looking at it. Put the decimal point there. 1, 2, 3, 1, 6, 3. We can kind of visually check it as well. The decimal's moved from there to there, so I've moved it 1, 2, 3 places. Yeah, right. This number in standard form, so I'm going to do it as 4.38. And then I've moved the decimal point to there from there. So I've moved it 1, 2, 3, 4, 5 spaces. So times 10 to the 5. Okay, and then final part, right, 4 times 10 to the 3 times by 6 times 10 to the -5, giving your answer in standard form. So I'm going to split this into a number part. So I wrote 4 times by 6 is my number part, and my standard form part, 10 to the 3 times by 10 to the -5. So 4 times by 6 is going to be 24. And then my number part is going to be 10 to the -2. That number's not in standard form though, so I need to convert it. So 2.4 times 10 to the, and then in effect we need to add 1, so it would be -1. So my answer is going to be 2.4 times 10 to the -1. Right, and then question 14 is work out the value of 0.004 times by 0.32. So when I'm multiplying by decimal numbers, I would treat it as just the numbers first of all. So 4 times by 32, double it and double it again, 6,428. So in effect, I've ignored 1, 2, 3, 4, 5 decimal digits. So I need 5 decimal digits in my answer. So my answer will actually become 0.00 128. So I've got 1, 2, 3, 4, 5 decimal digits now in my answer and in my question. So there we go. Right, if we look at the mark scheme then. So for question 13, part A, write as an ordinary number. So 0.01, yep. For part B, 4.38 times 10 to the 5, yeah. For part C, it is a method and then an answer. I've seen that be worth 3 marks before. It would be 1 mark there, 1 mark there, and then 1 mark for the answer. But I wouldn't argue that. Question 14 then. So method 1, method and answer. Right. Question 14. Car factory is going to make 4 different car models, A, B, C, and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information about the results. So we've got A, B, C, and D. Factory is going to make 40,000 cars next year. Work out how many Model B cars the factory should make next year. So we're going to assume that they're going to sell in a proportion that matches the people that like that. So I'm going to be doing 15/80ths times by 40,000. So I'm going to divide this by 80. So it's going to be 15 times by 80 goes into 450 times. Well, 8 goes into 40 divided by 8 is 5. So I'm looking at 500. And 15 times by 500 is going to give me 75 with 2 zeros. So 7,500. And then marks for this are just an M1 for the method and then an A1 for the answer. Right, and we'll move on to question 16. Work out the value of 8 over 27 to the power 4/3. So I'm going to treat this as 8 over 27 to the 3rd, and then I'm going to put it to the 4th. So the cube root of 8 is 2. The cube root of 27 is 3. And then I need to do that to the power 4. So 8 to the power 4 is going to be equal to 16. And then 3 to the power 4 is going to be 27 times by 3, which would give me 81. So 16 out of 81. Right, and that's it for that page. Okay, so marks for that then. How many have we got? Marks available, not overly generous. We have got M1 for method to find the cube root or find the power of 4. So we've got a mark there and then a mark there. Right. Question 17, complete the value for, and we've got a cubic. Okay. So a bit like the quadratic, I'm going to do these separately. So when x is 0, so I'll start with the easiest values. So when x is equal to 0, y would be equal to 6 times 0, which would be 0 minus 0. So y would be 0. Wrong one. There. Next one I'm going to do is when x is equal to 1. So when x is equal to 1, y would be equal to 6 times 1, which would be 6, minus 1 cubed, which would be 1. So that should be 5. Right. When x is equal to minus 1, written that very well. When x is equal to minus 1, then 6 lots of x, y would be equal to 6 times minus 1 would be minus 6. And then minus 1 cubed would still be minus 1. So we'd be looking at minus. Oh no, it's minus 1, so it would be plus 1. So it would be minus 5. minus 5 there. And then when x is equal to minus 2, y would be equal to minus 2 times by 6 would be minus 12. And then minus 2 cubed would be minus 8, but it'd be plus 8. I think we're looking at minus 4. Right. On the grid, draw the graph of, so when we've got minus 3, 9 as our first coordinate, we're going up in 2s. Not very clear graph, but that would be 9. Flat line in the middle. First point. Minus 2, minus 4. Minus 1, minus 5. I've plotted that point in the wrong position. Minus 2, minus 4, 1, minus 5. What was my next value? 0, 0. Then I'd got 1, 5. 2, 4. And then finally 3 minus 9. So that gives us a wave pattern. So again, spinning my page around, keeping this on the inside of the curve. So I'm going to do this part of the curve with my wrist here. Spaced that by accident. There we go. So that's the wave of a cubic graph. And that's it for that question. Let's look for the marks then. So we are awarding correct table B2 for correct table. So 2 marks. Oops, 2 marks are available for that. 1, 2. And then 1 mark for 2 or 3 values correct, and then 2 marks for this. These marks are fully correct. These marks are given for a fully correct graph. So I've got 2 marks, but it's 1 mark if at least 5 values plotted correctly. Right, question 18. Rizwan writes down 3 numbers, A, B, and C. A to B is 1 to 3, B to C is 6 to 5. Find A to B to C. Right, so combining ratios. So we've got A, B, and C. We've got A to B is 1 to 3, and we've got B to C is 6 to 5. So to combine them, my middle number B's are going to be 6. I need to times the first ratio by 2 then. And I need to keep the second ratio the same. So I'm looking at 2 to 5 to 6. 2 to 5. Sorry, 2 to 6 to 5. Wrong way around. 2 to 6 to 5. Okay, express A as a fraction of the total of the 3 numbers. So A is 2 parts out of the total number of parts, and we've got 13 parts. So 2 out of 13. Right, Emma writes down 3 numbers, M, N, and P. Find M to P. So we're doing ratios. I would tend to split this into ratios straight away. So a linear function to a ratio, I would need 2 lots of N to be equal to M. So N to M as a ratio would be 2 to 1. And then if we bring P in as well, we've got N to P. I'd need 5 lots of P to be equal to 1 lot of N. So 1 to 5. Combine those ratios, then I need to make my N the same. So 2 to 1 to 10 would be my combined ratio, but I want M to P. I only want this part of the ratio. So 1 to 10. Okay, marks for that question then. So we have got 1 mark for the answer, but 1 mark for combining the ratios. For part 2, sorry, for part II, we've got 2 out of 13. It does say a processing mark for showing 2 plus 6 plus 5, but I'm sure that you're fine with that. So I'm going to award 1 mark for the 13 and 1 mark for the fraction. For part B, we've got process to find an expression, express all numbers in terms of one number. So I'm going to go method and answer. All right. Question 19, then simplify 2 to the minus 5 times by 2 to the 8. So our rule here is we would add the powers, so that would become 2 to the 3 all squared, which would be 2 to the power 6. So 2 to the power 6. And that's it for that page. That's nice. So the mark scheme says M1 is given for a method to simplify the powers. So I can pick that up there, and then 2 to the power 6 is my final mark there. All right, question 20. The table shows some information about the profit made each day at a cricket club on 100 days. Okay, complete cumulative frequency. So I'm adding the frequencies. So the first cumulative frequency is 10. Next one is 10 plus 15, so 25. Next one is 25 plus 25, so 50. 50 plus 30 is going to be 80. 80 plus 5 would be 85. And then 85 plus 15 would be 100, which is what we were hoping it would total. Okay. Right, cumulative frequency graph for that then. So at the end of each of the groups, we would plot the cumulative frequency. So I'm looking at 50, 10, 125, 150, 50, and so on. So, so we've got 50, 10, 125. So we're going up in 25 would be halfway between those two. 150 and 50. We then got 280. We then got 250 and 85. And then finally 100, 300 and 100. Big surge right at the end. Okay, and then if I'm drawing a graph to match that, so drawing them with as smooth a curve as I can. And there we go. That's going to be my cumulative frequency graph. Okay, use your graph to find an estimate for the number of days which the profit was less than 125. So in effect, I'm going to go 125 up is going to be here. So go, get my ruler, trying to make it nice and neat. So at that point, I'm going up, and then from there, I'm going across. So we're looking at, if that's 30, and these are going in chunks of 2, I think that's going to be about 34. Do I agree with that? Just looking, so I think 36. Right. Use your graph to find an estimate for the interquartile range. The interquartile range is the difference between the top quarter and the bottom quarter. So if we've got 100 values from a cumulative frequency table, we tend to take the quarter marks. So change pen color again. Let's go red. So the upper quartile, or 3/4 of 100, would be 75. So 75 would be kind of here. So if I go across to my graph, not very well executed. But if we go down, and then the lower quartile would be 25. So again, if I go across to my graph, Right. Okay, so I'm looking at my upper quartile value is going to be 150. These are going up in tens, so is it? I think that's going to be, well, that point there would be 175, 80, not far off 90, just below, so about 185. My upper quartile, and I was actually looking at my table for this, the 25th value, just because I've spotted that the mark scheme is going to disagree with me here. The 25th value, I was thinking how close it is to 100. And it says that the cumulative frequency of 25 is 100, so that's slap bang on 100. So for my interquartile range, I'm going to do 185 minus 100, which would give me 85. Right, and then if we look at the mark scheme for that, then right, question maps over 2 pages. Switching for a weird pen color. Bring up a different. We'll go purple. Still not happy with that. Let's go change green for purple. Right. So we get 1 mark just for the table. Then we get our cumulative frequency table. It is M1 and A1. So 2 marks available for the cumulative frequency table diagram. Sorry, 1 mark for plotting the points, and then 1 mark for joining them. We've got a. I would get the mark. They're saying anything in the range 35 to 39, and then for the interquartile range, it's 1 mark for the method. Sorry, 1 mark for the method and 1 mark for the answer, and they're suggesting except anything in the range 85 to 95. And I would slightly disagree because they've used 95 as their interquartile range as their lower quarter, and I would disagree with that quite not strongly, but from the table that's not correct. But anyway, there we go. Right. Question 21. Question 21, we are looking at a cube is placed on top of a cuboid as shown in the diagram to form a solid. The cube has edges of 4 centimeters. The cuboid has dimensions. Work out the total surface area of the solid. Okay, so in effect, okay, total surface area. I'm going to still work out the total surface area of the cube because if you think about it, it's only this dimension here, which is going to be equal to the top face. So if I work out the total surface area of the cuboid and then add on these 4 edges or faces of the cube, that will be absolutely fine. So I'm going to say that the total surface area is going to be equal to 2 lots of 7 times 6 plus 6 times 5 plus 2 lots of 7 times 5. And then that would be the surface area of the cube. And then the 4 faces of the cuboid are going to be 4 lots of 4 times 4. So I'm looking for 2 lots of 7 times 6 is going to be 42 plus 30 plus 35 plus 2 lots of, and I'm doing it this way purposefully, 16 times 2 is going to be 32. So I can replace that with 2 lots of 42 plus, and then add these 4 numbers together. So I'm going to go, my units would be 9, I believe. My tens would be 3. Sorry, I've missed one off. I haven't. 9. My tens would be 3, 6, 9, 13. I'm looking at 2 lots of 139, which should give me 278. So I'm going 278 for that. Right. Is that it for that page? It is. So if we go to the mark scheme, the mark scheme is given, M1 is given for working out at least 3 areas found on the solid. So I'm going to go 1 mark for that. M1 for complete method to find the total surface area of, so I'm going to go mark for that and then a mark for the answer. Right. Question 22, here's a speed time graph. Work out the estimate of the gradient at t is equal to 2. So t is equal to 2 would be that point there. I need to draw a tangent at that point there. So I'm going to go there. I want the gradient of that line there. So I'm going to be fair, I'm going to take that as my triangle. So for that, the gradient of that line is going to be the change in y. So I'm going from 1 to 5, divided by the change in x, which I'm going from 0 to 4, so 4. So I'm going to go for a gradient of 1, which I think is reasonable. Yeah. What does the area under the graph represent? Area under the graph, it represents the distance traveled. So what's the area represent? Distance traveled. Travel. Okay, and marks for that. Let's have a look. So we are going, here's speed time graph. We've got M1 for drawing a tangent, and then M1 for method to find the gradient, and then M1 for the value. They've gone for 0.9, but I'm sure that what I've done is perfectly fine. For part B, distance traveled, distance traveled. Right. Two numbers, M and N, such that M is a multiple of 5 and N is an even number. The highest common factor, or HCF, of M and N is 7. Write down a possible value of M and a possible value of N. So in effect, the two numbers, I'm kind of looking at factors of them. The two numbers have a 7 in common. And this M is a multiple of 5 and N is an even number. So if I think about it, so it's got to be first even multiple of 7 is 14. It's not a factor of 5. So first even multiple of 7 that's also a factor of 5 is going to be 70. So to make 70, I mean, that would work, surely. Meaning that we would have, no, I'm going a bit too complicated on that. So we've got an even number. So I must have a 2 there. And to make this a multiple of 5, I must have a 5 there. So the could be 14 and 35 would be the most straightforward one. Yeah, so I'm going to go for 35 and 14. That's going to be the lowest possible pair. There are going to be others, I'm sure. Well, there would be others, but okay. And marks for that then. So we're looking at 23. Where's that? Okay, so M1 for method to find possible values for M and N. So go M1. No, I'm not. I'm going to go tick on my method, and then tick for my two values. There we go. Mark scheme agrees with me. For example, I can give any other examples, but give that one as an example. Right. Next question, final question. Okay, so Cormac has some sweets in a bag. The sweets are lime flavored or strawberry flavored or orange flavored. Okay, Cormac is going to take at random a sweet from the bag. The probability that he takes a lime sweet is 3/7. Work out the value of X. Okay, so from the ratio, it would be 9 over 13 plus X, and we want that to be equal to 3/7. So if I just say, or the simplified version of that. So let's just look at making the denominator of 3/7, sorry, the numerator of 3/7 a 9. That would be 21 over 9. So that, to make that work, X would need to be equal to 8. Okay, marks for that then. We have got B1 for setting it up. B1. So mark for setting it up like that. Mark for the method of working it through, and then a mark for 8. Okay, that brings us to the end of the paper. Before we move on, though, I'm just going to bring up the mark scheme, just because the last page of the mark scheme is very useful. There we go. So, last question then. The last question on the mark scheme, no, last question. So at the back of the mark scheme, they've got like a breakdown of the questions. So if you particularly struggled with one of those questions and you wanted to know what the topic was, it tells you the skills tested, which can be quite useful for specific revision. So I would definitely say that that could be very useful in your exam revision. The suggested grade boundaries, I don't necessarily think that they're useful at this point, because it's not been a full paper. But those are the topics, the skills tested. So if you want to do any specific revision, those are going to be your key topics. Okay, and that brings us to the end of this session. Thank you very much for taking the time to listen. Please feel free to add any comments, questions, or feedback in the chat, either on Teams or on YouTube as the videos appear. And I'll get back to you as soon as I can. So thanks again, and good luck in your exams.